Good morning, everybody. Well, maybe the time you watch this is going to be afternoon. After all, hello to you all. Hope you are you are enjoying your studies. Just to start this session, which is about your feedback for the lab session you had, I'm concerned that it seems to me that most of you are not watching my videos. I explained clearly that in my context, when I say lab, it's for rehearsal. It will never count for marks. So people were alarmed by the lab which you got on Monday, saying it should have been done this way, that way. That was just a rehearsal. There is no formula to arrange a practice session. It can be a surprise. No problem with that. It's good that way because it makes you prepared all the time. I wanted to use it so that I will be able to tell where you're lagging and we resolve it before your test next week. Next week is an official test. It's called practical. And if you check in your study guide one more time, it's confirmed there. There is no place where I said we're going to use your mark, we're going to calculate your mark based on your labs. It's going to be based on your precs. So please, if there's something you don't understand, don't create confusion in the group. Now, having said that, it takes me to another point. There are students who feel like it's better for them to receive a memo. I don't know how that will help, but to me, it won't, because as we mark, we look at your work and correct you where you got wrong. Now, a memo will only show one approach to the answer, a suggested approach, which I change as I mark based on what you give me. So if you get a memo, you will be taught one approach onto solving problems, which is not good. Unfortunately, if you go to, unfortunately, that will not make you a good technologist. You have to be innovative. So my personal feeling is I shouldn't bias you with a memo. If you've got problems, you ask, I should show you, yes, the memo and narrate it, make it understandable to you. So, but then there is a poll which is which was published, so participate. If you said you want the memo, that's it, I'll give you the memo. But I won't have time now to again do the feedback session because I know after the memo, there will be a lot of follow-up questions. I'm not discouraging you from that, but my experience tell me, if I put a memo, some will even be tempted to use this. If a similar question come in the test, they will even be tempted to just reproduce what is in a memo. And that is plagiarism. They will be in trouble. All right, without further waste of time, let's look at the work which you had to do for the lab. And then I take you through my suggested solution. Okay, there is the questions. Along it, there's gonna be answers, right? So you already familiar with these sections of your question paper. If you ask student surname and initials, right? It should be, it started with surname and your initial, and there is your student number there. You put it nicely. And it asks you for a time-stamped photo and a location. So if you look into that, you will see that there is address and the date as well as time. That, of course, is going to be a picture. So you are lions. Oh, well, you've got strength. I believe you can make it. You can do it in the subject. Right, here it was there was your question. Okay, now, having that, you need to use the last 2 digits of your student number in kilo ohms. That will be the value of your potentiometer right there. Right, in my case, there's my student number. It adds up to 9. It means then that will supposed to be 9K, the resistor which I have to be using. Okay. So, and then I have to build a circuit. You can see there is my potentiometer, which works out to 9K. Right. So the first part of the question was to derive the equation for the transfer function. So which is the ratio of the input to the output. So output divided by input impedance, which is the same as Z out over Z in. We need to re-sketch this using the impedances for each section. So for inductor, it's just omega L, not the problem. For resistor, it remains R. Be careful with your terminology. If you say omega L without putting 1 subscript 1 or subscript 2, it means that L is the same. It's the same thing, like here. So we have omega L and omega L. It means the value of L for both is the same, as it is the case. That one, it tends to be the same with that. So that is the reason why we didn't use L1, L2. Now, we've got R. Now the potentiometer is RP for potentiometer. Don't confuse P with a symbol for Laplace transform. And right there, C is the only C. We don't have to put a subscript, which is 1 over omega C. So now, the input impedance, we'll be looking at this area. We only exclude that. So it's the sum of everything here. So there you see omega L, 1 over omega C, and then R and RP. But as far as the output now, we're looking at that. The only thing we're going to exclude here is this omega L and this R, RP. So there we have that, and then 1 over omega C and RP. So we take the ratio of the two. That for each part here, it was 2 points, 2 points for Z out, 2 points for Z in. Then you put them onto that equation, 2 points, and then you simplify. To simplify this, we just have omega C to multiply the top and the bottom. So you result with that. That is 2 points. Now, I told you there that through experience, I've seen that when you want to transfer this to Laplace transfer function, if you say V out of P, rather than saying Z out, you'll have to make where omega, you make P, that P or S if you were using S for Z transform. So the alphabet that signify a Z transform. So there it is, it could have been your output. Now, one thing interesting here, if you look at that equation and that, there you divide, or rather, you can even say here, you divide omega into 1. So you take a reciprocal of omega. So the moment your frequency is 0, then the value become infinity. It makes everything infinity. That you should note. But once you come to this simplified version, you don't take a reciprocal of frequency. So you can be able to get your results there. Just note that we'll use it when we carry on with your answers. Now, so when we start this, we have Z in for calculated. So Z in, if you go to your equation of Z in, like I said, you're going to be taking the reciprocal of omega at some point. Where F is 0, it will give you infinity and make the whole equation infinite. Same as Z out. But the resulting gain, if we go to the equation of the resultant, Z1, there is nothing which goes to reciprocal. All is going to happen then now is you're going to have every point which has got F to be 0. So everything then will be left with 1 and 1. 1 divided by 1, then that will give you 1. Then as we measure now, it means then we must build the circuit, put this to 50% and do measurements. Let's go for it. So you will quickly build this. Just again, coming to the issue of memorandum. You have a suggested circuit. So does it mean if you sketch this in a different way, I must mark you 0? No, there are so many possibilities. You can sketch it moving from top to bottom, and you could like put this meter not this way. So it's up to you, but the memo is suggesting this. Now, while you can see I already put other sources for which I used in other questions already, and now I will switch them off because initially they are not there. And then from there I run, and then I will check my Z in there, I will check my Z out there as per connection. XM2 input, XM1 output. Let's see. Let's run it and have a look. You see there, it's not giving any value. So that is your infinity for both. And infinity divided by infinity will be what? Something which you will never define, right? So if we go back to our answers, so for measured, it's populated with infinity. Okay, now, for the second part, we'll move to a 12-volt DC supply. So we connect it to the input, right? And then from there, remember the port is what's at 50%. We didn't check that. We can just check it was 100%. Not a problem. You can increase it before you run. You can increase it whilst you're running. It doesn't make a difference. Let's just verify if those readings were true. Yes, they were true, even at 50%. But now, we were on the second part of the question where we need to connect a 12-volt DC supply. So it means we're going to activate that, stop running first, activate it, and then change to voltage. What voltage? DC. And voltage again. What voltage? DC. And then it's 12 volt. Now we measure. Let's start with the calculation, maybe perhaps before we run. When we look at the formula there, this will be open circuit, it's DC. So if it's open circuit, there is no current which is going to go there. And then this will be, it's an inductor, it's a wire. It will just pass current. So that resistor will connect the input and the output. So whatever in the input will be at the output. What do you have at the input? 12 volt DC there. So it will be equal. So calculate 12 volt gain is 1. Now let's have a look when we run, if that is the case. And then we run 12 volt, then the gain is 1. That's what we have. So we can stop that. Go back to the next question. We calculated the 1. So each point here is going to be 1, 1, 2, 1, 1, 2. And then there's 3, 3, 6, making it 10. That's how the map was made. Now we have to move in steps of 25, right? If we look at V in, it remained at 100 volt. We look at V out, it changed this way. So let's see, let's validate that because it's already done if it's true. And then we remove the DC source, we put the AC source, and we put this on AC now. We put that on AC. We're gonna start at where? 0. And we run 1.585, remember that, and 100. 1.585 and 100, it's true. We move to 25%. Might be difficult to do that. 25%, 100, 69.224. 100, 69.225, fair enough. We'll go to 50 now. 100, 81.816. 100, 81.816. Fair enough. And then from there we move 75. 187.095. Fair enough, that is, and then we'll go to 100%. That is the final one. 100%, 89.998 and 100. 100, 89.998. Okay. Right, that is rounded to 0.9. So 0.89, which 0.89 and other digits, which is rounded to 0.9. So that is because you divide 100 by that. Okay, so that is true for everything. So now it was not the end of all questions. So these are your results summarized: 90 and 100, which give you 0.9, 187.87, 181.82, 81.8 there, 169, which give you 0.69, 101.5, which give you 0.015 as a gain. So that is what you had to get. Now, how do you compare the two? For both DC and open circuit, the capacitance reactance is infinity. So that's when, before you take the ratio. And then from there, it's difficult to use that out of ZE. You can only see it when we put a DC, that 1K determine the output to a unity gain. And if you look at this, that's where we're going towards a unity gain as we change the resistance. But anyway, that has got nothing to do with the ratios. Now it has something to do with the port. And when AC is applied, then yes, that's when we could be able to use a variable resistor. We are able to control the gain because you don't have infinity on the capacitor. Then you were asked to attach a screenshot. If you check the mark, it will add up to 55. So that 5 goes to your screenshot. There it is. There. Now, this is how we will be marking. Now, what do we have there? The first part, which you submitted after 1.5 hours. Question 1.4, on that where you had table, it was for AC supply, and then the other one for DC and no supply. That one, it carry all of them, they carry 5, a weight of 5. So I can come and say to you, right there, let's check this. If you got everything right there, it means you got 6. 6. And then 6 times 5, it will give 30. And then if you got everything there, you will have had 25. But that will go with this one, the first part of this thing. I'll add it with the second and check. Do you have a second? So if you got it, maybe half of it, so it means you are on 3. So if you got 3 there, and then I will multiply 3 by 5 and then write 15. So 15 plus that 30, which I mentioned earlier, is giving you 45%. That's gonna be 45 out of 45 for the what you did in class. We still have to add in your report. Then your report will come up with a mark, so you get 40 there. So it's gonna be 45 plus 40, which makes it 85. So that's how we do the marking. And with that, it brings us to the end of your feedback session. So choose, I mean, this is a pre-recorded video. You can make screenshots and compile your own memo. But the nice part about it is that you will never edit, make it into another version, which you're gonna replicate it. And you won't have to go and ask me questions because all answers are there. It saves time and it will enable you to get everything. But then if you choose a memo, it means then I'll send you the memo. You don't understand it, it's your baby. You phone me, you still don't understand, then that's gonna be a challenge. I see the same thing when assessing the test, you taken to the committee for discipline, right? Up to you guys. With that, I will end this session on your feedback and have a nice day.